I want to start with something that I found very interesting. And we talked about new insights and things. And this is something that you may or may not have seen before. It's a diagram called a Necker cube. Basically, it's a wireframe cube, but there's no clues as to which surface is the front. So if you're looking at it, sometimes it'll look like the right side, right? You're looking at a top-down view. Sometimes it's a bottom-up view, right? Can you see that? Right? Okay. So this is your perspective on things, how you look at it. And a slightly different version of this, right? Now, it sort of looks like a white Necker cube on top of some black dots. Can you see that? Okay. Try this one. Imagine that the white is a piece of paper, and you're looking at holes to a black background. And the cube is behind the paper. Can you see that? Okay? That's pretty amazing. Nothing has changed on that screen. The only thing that has changed is how you're thinking about it. Okay? And you can see the cube on top, you can see it behind. There's no cube there, actually. There's no holes, right? It's just little sections of black circles, right? So as we go through life, what you see is oftentimes based on how you think about it. And that's going to apply to this talk. So who the heck am I? Okay, I've done some things, I've worked with people. I'm certified as a Java programmer developer by Sun, so this happened a long time ago. Currently I'm working with Daugherty Business Solutions as a technical architect. I do a lot of coding. I also got to contribute to a couple of O'Reilly books. 2 of the 97 things in each of those books are mine. And if you like playing Where's Waldo, you can find my picture on the cover. The goals for this talk, though, based on the little blurb, if you read it, we want to learn how to efficiently design, implement, and test so that your resulting code is clean, flexible, and easily maintained. Why is that important? That's a question. Why is that important? Well, if it's not easy to maintain, then the code gets uglier. Laura talked yesterday about the big ball of mud, right? No code starts off like that. It builds up that way over time. Well, no professional code starts like that. Okay. We want to have business requirements that always describe what the system's supposed to be doing. Have you ever been on a project that's in production, and you join the team and they say, yeah, we've got requirements, but those were written a couple years ago. It does some other things now. Not very helpful. How about user docs, developer documentation, right? There's people who comment code, hate comments, because you can't trust them. They don't execute, right? They might have been accurate at one point, but after a while, they're not maintained, or somebody does something, doesn't have time, I'll go back and comment that later. So you can't really trust them. But if you have documentation that is accurate, that's very useful, right? The last thing is, we want to have a safety net. How many people here do some form of test-driven development? You tried it, yeah? Okay. We'll talk more about TDD later, because that's part of this. But one of the key pieces of that very few people take advantage of is refactoring. Refactoring is changing the internals of the code, not how it behaves externally, but cleaning things up inside, making it nicer, making it run smoother, maybe making it more efficient. But if you don't have something to help you be sure that the change you've just made isn't going to break something else, you can feel like this guy. Okay, ready to make the change. I hope it works, right? And if you remember the scene, you know how that turned out. So this is all based on feedback loops. Right? Being efficient is getting feedback. So feedback tells you how things are going. Right? It gives you a chance to make corrections. Right? We're doing this, and maybe we can do a little better. One of the typical feedback loops is, right, I'm doing something and it hurts, so I want to stop. Or when you're driving, you're getting feedback, I'm getting too close to the car in front of me, or I'm getting to the edge of the road, I need to adjust my steering. So because of that, shorter loops are better, right? The more often you've got a chance to change things, the easier it is and less chance you're going to get in trouble. So the traditional software process has lots of opportunities for feedback. You read the requirements, We do some analysis to figure out what we're going to write. We write some code. We manually test and find bugs because there's going to be bugs, right? And it doesn't matter what language you use, doesn't matter what process you use, there will always be some bugs. Well, that's your first feedback loop, right? And generally, it's not too long. Right? You don't write code for days and then start looking to see, does it work? Might be a couple hours if you're really into it. If you find a piece that's really interesting or really difficult and catches your attention. That's a reasonably short loop. You then turn it over to QA, right? They find bugs, there's your second loop, because the QA is going to hand it back to you, okay, that needs fixing, so you do analysis, you write the code, manually test, like that. Then eventually you get to hand it over to user acceptance testing. Same thing, they're going to find some bugs. It may be that a requirement changed. That's still considered a bug because it's not doing what they want. So you've got another feedback loop. Finally, production, and users find some things. Now, when I first built this, I got depressed, right? If I'm thinking about this, I'm spending time doing all of these things. And every step of the way, you're finding bugs, and you have to go back to the start and do that analysis to figure out, okay, what did I not quite get right? Maybe you have to go back and talk to the business people and say, okay, I thought you wanted this, but this seems to be wrong. That doesn't make any sense anymore. So people came up with the next step, which was adding automated testing. And this happened for Java developers sometime around 1996, 98. JUnit was very popular. You couldn't read an article on how to program in Java without seeing three things. There were design patterns, there was UML, and there was unit testing. So basically you do the same thing you would normally do, but then after you've gone through and found the bugs and fixed them, then you write some automated unit tests, probably using JUnit. Still very popular. You'll find some bugs when you're doing that. And so there's another feedback loop in there, right? And the rest of the process. And they all take time. So the thing about this is, writing automated tests last is very difficult. And part of that is because of the way our brains work. Right? I've just spent some time, say an hour, writing code, another 30 minutes debugging it, right? Making sure everything works just perfectly. And now I'm going to sit down, I'm going to write an automated test that just does what I did manually. There's no value in that for me. Why would I do that? I could be fixing something else. I could be putting in a new feature. I could go home, right? So it's very hard, and that's why most people, most teams that use a test last process don't have very many unit tests. Unless you've got a build process like Jenkins or Hudson in place that says, I must have 80% code coverage, right? The tests aren't going to happen very often because it's hard to make yourself do something when you don't see any value in it. Now, 6 months later, if that test existed, you might be very happy. But in the moment, everything tells you, I'm wasting my time. So then there's the idea of test-driven development. And some of you have done it, but we're going to take a sidestep for a moment. So, test-driven development is a very simple process. It has 3 steps, right? You write a failing test, you write the production code to make the test pass, and then you refactor, right? Clean up any mess you made. It could be duplicate code, it could be there's a better name for this method or this variable, but you clean that up and then you write the next test. And when you can't think of any more tests to write, you're done. Sounds very simple, right? Uncle Bob Martin, who I think Laura mentioned yesterday, a couple of people probably mentioned him, he has some rules that make it very interesting and more efficient when writing unit tests. His 3 laws. First is, you can't write any production code until you've got a failing test. That seems reasonable. Second thing is, failing also includes compile errors, right? So if you're writing a test for a class that doesn't exist, as soon as you go to instantiate that class, you've got a compiler error. So now you get to go write the production code to fix that. But you can only write enough production code to take care of that problem. So just because I don't have the class yet, doesn't mean I can go ahead and create the class and a couple of helper classes and maybe something else over here that I think I need. I can only write the class definition, because then the compiler will pass, and I can continue. My IDE will be happy, and I can go. So now I start to talk about a method in the class. I've got a compiler error. I go create the method, but don't put anything in it. because there's nothing that tells you what to do there yet. Right? So that's how that works. And it's very efficient. Your cycle time on that is somewhere around 30 seconds to a minute, I mean, depending on how fast you type. And the great thing about that is, if there's a problem, you hit Control-Z a few times and you're undone. You have no issues, right? You can't get very far down the bad trail before you've gotten some feedback that says there's a problem here. So that's Uncle Bob's 3 laws. The problem is, if you've tried TDD, you can see that even though it's supposed to be a simple process, it can be difficult, right? You guys have had this issue? That's part of the reason why we didn't have 80%, 90% people with their hands raised. You read the article or you go through the tutorial, it makes sense, somebody told you the three steps, and it's like, yeah, that's easy, I can do that. And then you sit down to do it. And the question is, I don't know, I'm not sure what I'm supposed to do here. But the people who've done it will tell you it's easy. And it is, once you know the secret. The first question that comes up with this cycle is, right, how do I know what test to write? I had that question years ago, and when I posted on a forum, I was told, if you don't know what test to write, you don't know what production code to write either. And that wasn't very helpful, or so I thought. Turns out to be very true. And we'll talk about another piece. First, we'll go through this. The process with TDD, you do read the requirements, do the analysis, write enough of a failing test, right? Write the code, make it pass, and there's your tight loop. Refactoring, there's another tight loop, right? So this is very short and fast. The rest of it goes like the rest, because we have no control over what QA does. We have no control over what UAT does or what happens in production. We can't do a lot to modify those loops, but using this process, that I'm going to talk about in a sec, you can reduce the number of times you have to go through those loops, right? So if it takes 2 weeks to go through QA, and you can go from having to do it 3 times to once, you've saved a month, right? If you can do that with UAT, which keeps you from having to go through QA again, right, you save even more time. So what we do in our little portion of this feedback loop can make a big difference. Times, yeah. And I say, if you're doing this, you will rarely find bugs in production because you've written tests before you write the code, so you know everything works before you get to it, before it gets out there. Behavior-driven development is sometimes called TDD done right. Because what behavior-driven development does, it says, start with the business requirements. Take the user stories. That's what you base your tests on, okay? You don't have to try and guess, well, what do I need to do to build this? You've got a requirement that tells you, this is what the system is supposed to do. So for each requirement, you talk with the business people. If you have QA people, have them in the room too. And the 3 of you sit down and figure out, for this requirement, let's look at some concrete examples, right? If it's a login, okay, the user supplies their credentials and they're good, they're accepted. They supply their credentials and it's not acceptable, they get told, invalid, please try again. After 3 times, they're gonna get locked out of the system for some period of time. You've got concrete examples there of what the expected behavior is, right? It may go so far as to say, display this particular message or not, right? But don't get into the details of implementation, right? So for example, if you're working on something like an ATM, right, and the business requirement is the user has to identify themselves, right? Don't have the requirement say they have to punch in their PIN and push the enter button, because if the implementation changes to voice recognition or reading your iris or mental telepathy or whatever, the rule now is your implementation is going to fail, even though the business requirement, which is the bank customer has to identify themselves, that's not going to change. How they're identifying themselves might. So implementation can change. Keep these high-level things. You then write your specifications based on these concrete examples and use those specifications to drive the lower-level things, right? So that high-level piece is going to drive a lower-level test or lower-level specification. What are the subsystems here going to have to do? And those will eventually drive unit tests, right? Which you can do TDD style because now you've got something to tell you exactly what's needed. This is what the process looks like. You start with your failing end-to-end test, right? The user submits their credentials, and now you've got lower level stuff. And there may be several lower levels here. And we'll see some of that in just a sec when we get into the code example I've got for you. But the process, the feedback loops look like this. And that write code to meet the spec using TDD, that's that small three-phase cycle, right? Failing test, code, write the code to make the test pass, and refactor. So this, like I said, they call this TDD done right. There's books on this stuff. It's not hard to find out there. But if you do this, I can tell you that from personal experience, you'll get done a lot faster than you expected. I was brought in at a client's. They were going from a waterfall process. They wanted to do extreme programming with TDD. I snuck this in instead because it's a flavor of TDD. The goal was they wanted to have this project into a pilot situation. So from development into some of their retail stores in 5 months. They had done a similar project earlier, and it took them a year and some time. This was a smaller project, but they understood the domain. They understood what they were going to have to do. Their best guess was 5 months. I sat down with another developer, and after 5 sprints, 10 weeks, we were into pilot. By the end of the 5 months, we were into full production. Okay? They had never done this before. This was my first time sitting down with somebody else and walking them through it. I'd done it before myself, but this is the first time working with another team. So 10 weeks, we were into production instead of 5 months. That's not bad. So executable specifications, this is another term for it. These are specifications, business requirements, that you can actually run your code against and prove that it works. So for the example, people like to-do lists for some reason with microservices. So I've got a to-do list example. And the business requirements look like this. When a task is added, it should show up in the list. The list should not allow duplicate tasks. When you're asked for a task, when the list is asked for a task that it contains, then it should return that task. So you should be able to get individual tasks from the system. And when a task is deleted, it should no longer show up in the list. So you take one of those, and when the list is cleared, it should be empty. Those all make sense, right? There's not a lot of specifics in there of how it should do things or what methods I should call, anything like that. Those are reasonable business rules. So we'll switch over and look at code. And this is where Spock comes in. Spock is a BDD framework written in Groovy. Don't let that scare you. Groovy is a language that was designed for Java developers. Groovy does for Java what Java did for C++. It makes it easier because you have to write less code, and it makes it more powerful at the same time. You will notice a few weird things here. This is a method, but instead of defining what it's returning and the access level, I just say def. I'm defining something. In this case, it's a method. Here's another method, but the method name's a string. Groovy lets you do that. It's kind of nice. Now, instead of just having a test method called test get task list, if I'm lucky, or get task list 01 because there's more of those, right? That name doesn't tell you anything. This name actually tells you when a task is added, then it should show up in the list of tasks. The next thing you'll notice is there are blocks here like this, when and then. These follow some of the things you'll see in user stories, right? Given, when, then, or when this, expect that. The when and then, those are just Java labels, and then it's followed by a string, right? Doesn't actually do anything. If there were no code, if I took out this statement and these statements, right, and just left the when, thens, this would pass just like an empty JUnit passes, okay? But these blocks of code define things. So when is telling it the event that I'm going to have occur. So I say when, and define an added task, there's a variable. and I say add random task to the list. Okay, nice high-level thing. So that's going to return the added task. Right? So when a task is added to the list, then the service should return the added task with an ID value. The list of tasks is requested. When the list of tasks is requested, then the freshly created task should be in the list. This parallels what our business requirement was. Right? This is an end-to-end test. The question about adding a task to the list eventually does this. I'm calling an HTTP, making a request here using the REST template, right? So doing a post, passing the data, and getting back the return, right? Very little implementation-specific stuff here. I could rip out the implementation, leave the stuff in the get, in the when-then blocks, and put in a completely different implementation, and all the tasks should still run. So this is documentation that's being executed against the code base. It has to stay in sync, otherwise tests are going to fail. This is also high-level stuff. So this is like your business requirements. It's in a separate project than the code, the production code. So this is my to-do list of user stories project. The to-do list services project is down here. And this is where the lower level tests, the integration tests, and the unit tests come from. So this is what, so you write that high level test, right? The user stories here, and these are going to fail as soon as I start writing them, right? So I created this part first. I said, okay, I'm going to add, well, to be honest, I refactored that. I first put in this code to go ahead and send in, to send a task to the list, right? Say, I want to create this task. And of course, it failed because, well, no. When I executed it, failed because there's no class out there. There's no service out there. So in order to make that work, I had to go ahead and I used Spring Initializer. I said, I want to create a Java boot project, Gradle, and gave it the different dependencies I needed. And that became the basis for this project. And in there, the first thing I did was created this service spec and the first story saying it should remember added tasks, right? Given I've got an empty repository, when I add a task, it should have that one task, and it should return the task that I gave it, but with a task ID. So now I know it's in the database, except there is no database. So when I wrote this piece, it failed. I've got no service that does anything, so I had to create the service class. There's no method for adding the task, so I had to create that. Right? So eventually, that gave me this, my controller, right? And the first piece was the post, right? It's showing the colors because I ran the code coverage piece. But so creating that integration level test forced me to go ahead and start creating unit tests. And unit tests, as those start passing, the integration level tests start passing. And as those pass, eventually your high level business passes. The other nice thing about Spock is there is a library that goes with it called Spock Reports. It generates HTML pages when you run your tests. You don't have to do anything to it, just add it to the project, and it'll generate this report. So you can see here, these are the high-level business requirements. Right? And these are the different steps that are involved in there. They're all passing now, so you know that it still works. It does what the business wants it to do. That value has been created. Right? And then for the developers, you get more into this side of things, where right, I've got two primary tests here for specification. You'll hear people use the word specification instead of test. There's a reason for that. Part of it goes back to your brain again. A test is something that you do afterwards, right? I've done this, now I'm going to run a test to make sure it works. A specification is something you do beforehand. I'm going to specify how I want this thing to function. And then it's up to you to figure out how to make it work. The fun part about this is that specification can then be used as a test to show that it is doing what it's supposed to do, right? And it also becomes that safety net for your refactoring process. Because when you go in and you make a change, if it's not behaving the way it was, the specification, the test is going to break, and you know that you've got a problem. You undo what it was, or you go in and decide, no, actually it should do this new behavior, and talk to the business guys, make sure, yes, that's really what they wanted, because sometimes you get a requirement that comes in that says, oh, do X. Well, right now it's doing Y. Do you really want to make that change? And they'll think about it and go yes or no, right? But you've got something that's going to help you right away find out that this new business feature, this new requirement they've given you, is conflicting with existing requirements. And if you've got a legacy system you're working with, or something that you've had in production for even 6 months, you may wind up with something like this. Currently we're adding a new customer loyalty program, okay? And silver medal people get 10%, gold level people get 20% off. Great, okay. What happens for things that are on sale? Do we still apply the extra discount on top of that? No. Don't apply the extra discount, because now we're losing money on it, right? If it's on sale, those customer loyalty things don't kick in. Or maybe they do, right? And you just decide it should be whichever one is a lower price for the customer. If they're gold and they get a better discount, then you give them that. But this drives those conversations with your business people much earlier in the process, which means you've wasted less time writing something that you think you needed and didn't. So, go back here. I like comics. There's a lot of truth in these, right? People have been hoping to find a way to get rid of programming for decades. If only we could come up with a clearer way of stating our needs. There is one, right? It's called code. And for the foreseeable future, it's going to be the same. So as developers, the best thing that we can do is learn how to cleanly and efficiently create the code that we're going to use. So I've got some recommended resources here. Clean Code, Uncle Bob's book, right? Growing Object-Oriented Software Guided by Tests. This is a fairly recent book. It's called the Goose book, G-O-O-S. Specification by Example. There's another excellent book. Gojko Adzik wrote this, and he goes through all the steps. The Goose book, these guys start off from scratch, and they show you how to build a walking skeleton. If you're not familiar with that term, a walking skeleton is all of the code you have to get from one end to the other of your system, but just the bare bones, right? There's hard-coded values on the domain side returning, so you're not actually hitting the database and doing things yet, but you can have a request come in from the web, hit your controller, call all the pieces it needs to, and come back out. You start with that, and then you start building your tests on top of it, using your specifications to figure out what I need to build and how it's supposed to behave, and how do I know when it's done, right? So, and the last thing, BDD in Action is another very recent book, and it covers a lot of this as well. And that's it. You have questions? I know there was a talk yesterday I missed. People were in the open space. There was a question about test-driven development. It's real, it works. Yes, sir. Okay. So what I normally do is I'll put unit tests in one directory, usually source, test, Groovy, right? And then I'll have an integration test directory and put the integration test there, and then a user stories directory. When I was working with this, what I found was when I went to run the end-to-end tests, those initial business level requirement ones, Eclipse, Spring Tool Suite, was actually starting up the application each time. And that's not what the end-to-end service, end-to-end test expects. It expects to have a service running, and you're going to hit that service and get responses back. And because it was starting the app server every time, there was no memory of previous things. Right? And I wanted to have that in there because when you run these tests, these aren't just for you. Right? You can take those end-to-end tests, run them in development, in QA, in UAT, and against production. And what that means is you have to write smarter tests. Okay, if I'm writing just my own stuff and I'm testing, it's like, okay, when I add this task, I know that there's only one task in the whole thing because I've just spun it up and added one task. But if I'm running against production and I add a task, right, and I say, okay, give me the list. There should be one item in it. It says there's 507. What? My test is failing now, not because there's anything wrong with the code, but because the environment is not what I expected. So you have to write smarter tests. Right? If I'm going to write a test for that, if I'm going to write a test that says, okay, when I add this, I should have more tests or more tasks, right? Then the test would do something like, get me the list. Okay, I've got 506. Add one. Get me the list. I've got 507. Is mine in there? That's the better test, right? I just added this task. Is it in there? Now, if you have something that says you can't add duplicates, and you're just basing it off of the description, then you could have problems. I want to add the task shave yak, right? Somebody's already added shave yak. So when I go to add it, it fails. It says, conflict. This already exists. My test fails because it didn't add it, right? So the first thing I've got to do is have it look. Does that task exist? Or have some other way of making it unique. Right? Put a timestamp on it, right? Milliseconds. Pretty unlikely that task is going to have the exact same time and the exact same description. But that's the reason I had a separate project for this. Is I wanted to be able to test it with an environment where I didn't have control over what was in there. So, and that's the other thing. Like I said, the business tests you want to be able to run against all your environments because they should hold true all the way across. And you can run into issues if you don't do things like this. We've got a project where the business people wanted a dump of a database table. They weren't allowed to look at it in production because people were afraid that even if they had read-only access, they might do something like a table scan and just slow everything down. So there's a button, export table. And this is an Angular client. And what it does is it goes and says, okay, server, give me the first page of data. And they're doing pages of data because the table can get pretty big, and you don't want to try and shove, a gigabyte back on a HTTP return because it's not going to fit. You're going to time out, right? So they got smart. They said, well, page it. How many pages? 80 pages. Okay. Put it in a loop. Ask it to get me the first page, the next page, the next page. Well, if you know Angular or JavaScript, JavaScript's single-threaded. So when you make that call, it is not a synchronous call. It's an asynchronous call. So you've just hit the server 80 times saying, give me a page, give me a page, give me a page. Turns out the database server, or the database connection, has 100 threads. Okay, I've just launched a denial of service attack against my own software, right? So the guys, some of the developers who were working on this, they got a bug saying, how do we fix this? And I asked them, I said, well, so what are you doing with this? What's the business need here? And the business need was, well, around 5 o'clock every day, they want to take a look at this table because it shows them all the things that have happened and if they need to be concerned about it or not. I said, okay, so why are we doing this whole export to the UI thing? I said, well, because they need to have the data, and so we create a file. And, well, what if you had a service on the back end that at 5 o'clock creates a copy of the table, zips it, and emails it to them? Oh, maybe that would work. That's not a bad idea, right? So part of what we have to do is have conversations up front when you get those business requirements saying, I want to, why are you doing that? Is there a better way, right? Don't accept the first implementation that they try and give you because a lot of times they'll try and do that. And by putting these business rules in terms of a high-level specification, this is how the system should behave, not this is what it does, right? Not punch in your PIN number and hit the enter button to identify yourself, but high level. Customer presents acceptable credentials, whatever that may mean. Right? It lets you free up some thought for more creative solutions to things. So I hope that was a long answer. Other questions? No? Okay, well, then I thank you for your time.